The radius, yeah, okay. So that is a radius. The distance from one side of the circle through the center and on to the other side of the circle in a straight line, better than mine, has another name. Does anyone know what that is? Yes, diameter. So there is then a special relationship between the radius and the diameter. What's that relationship? Schlock? Okay, even more so numerical, yeah. Yeah, radius is half the diameter, or the diameter is the same as 2 radiuses, or radii. So 2 radiuses is the same as the diameter. Okay? There's a few other words that we associate with circles that are kind of unique to circles. For instance, we don't call the outside of a circle the perimeter of the circle. We have a different name. What's the name for the outside of a circle? The distance around the outside of a circle. Flynn? It is the circumference, yes. So circumference is this different distance if we walk around the outside of the circle, also known as the perimeter in any other shape, but a special name for a circle. The circumference is the distance around the outside. Okay. In other shapes, it's called the perimeter. There's a few other slightly different words with circles. We have, if I have a part of the circumference from here to here, let's say, what's part of the circumference called? Does anyone know this? No, it's called an arc. And that's called an arc, A or C. It's part. That's called part of circumference. So it's a part of A or C. Maybe I'll write that bigger. A or C, arc. So the arc length would be this distance here. And then we have created a little pizza slice here. I don't know if you see that, the pizza slice here. What's that? There's a special name for that slice. Lanny?
I've got a question.
Oh, yeah?
Does this work for an oval as well?
No. The circle is a very special shape and it's different than an oval, yeah. So this pizza slice is called a sector. That area there is called a sector. Some unusual names. Also, we'll do one more maybe. If I have a line that doesn't go through the center of the circle, has a name as well. It's called a chord. It doesn't go through the center of a circle, it just goes from side to side of a circle, but not through the center is something called a chord. All right. All right, so that's the main names of a circle. And then quite often with a circle, we deal with a very special number. The very special number is written above here. Pi, yes. So we have a symbol, this, we have 2 letters, pi. That's the symbol. And it's around 3.14 or so. 3.14, 1.9. Yeah. So it's interesting, mildly maybe, how this number is created. Does anyone know how this number is created? Or did someone just come up with it? And why is it important? Lanny? It's about the fact that a circle is a unique shape. Not that it goes forever. Yes, you can go round and round in a circle forever. Yes, that's correct.
But you can also, like, for example, if I have a circle of paper, I can cut it in one point and turn it into a line.
Yes, you can. Yeah. So you can measure the length of a circle.
That would be the circumference.
Yes. So if I ever wanted to measure the length of the outside of a circle, if I had no equipment, I could use just a piece of string and put the string around and then straighten it out, and that would be the length. Okay, so if I knew the circumference of a circle, if I measured the circumference of a circle, and I measured the diameter of the same circle, So let's say you have your water bottle, or you have a glass, or what else? The earth, the flower, all these things. If I measure the circumference, so the distance around the outside, and measured the diameter, and divided those two numbers, I will get pi. Which is weird. It's weird for a number of reasons. It's weird that the ratio of the circumference, the length of the circumference compared to the diameter, the circumference is always 3 and a bit times bigger than the diameter in every single circle. Every single circle. So any circle, this distance is 3 and a bit times this distance. So you can lay out 3 and a bit diameters around 1, 2, 3, and a little bit left over. Diameters around the outside of a circle. That's kind of strange. Lanny? So Finn came up with a way there. If you have a piece of string, you can lay the piece of string around the outside of, and then straighten the string, and then put it against the ruler. That's a good way of doing it.
Or like
Now,
get like, for example, the clothing tape measures that.
yeah, you could wrap a tape measure around a circle. Okay, now this number is special for another reason. It is irrational. What does that mean? Irrational numbers, it's got to do with the dot, dot, dot here at the end. Lanny? It goes on forever. Now, numbers can go on forever. This decimal goes on forever, but there's no repeating pattern. For instance, we're used to decimals going on forever. If we do 1/3, that's 1 divided by 3. 3 does not fit into 1, so we go into some decimals here. We carry the 1 over to tenths, so 3 fits into 10 3 times with a remainder of 1, and we end up with this recurring thing. So, but there's a pattern here. 0.3 recurring can be written as 1/3, and there's a little algebraic trick which I'll show you someday to write that as a fraction. This one does not have any pattern, no discernible pattern. You could check all the numbers up here. There's no discernible pattern at any stage in that number, and that number does go on and on and on and on forever. So if I have a circumference and I divide it by the diameter of any circle, I end up with 3.14159.265 and so on forever and ever and ever, presuming my measurements are perfect. Now, if you want to think about that, how large that number is in another way, if I assign letters, A is 1, B is 2, C is 3, and so on, your entire life story is written in this number. And the person beside you, and everybody in the room's life story from birth to this point has been written in pi. And it's been written with 1 spelling mistake, and 2 spelling mistakes, and 3 spelling mistakes, and 10 spelling mistakes, and 200 spelling mistakes. So every single work of fiction, every book that's ever written is in pi, using this system, just assigning a letter to a number. Every one. With 1 spelling mistake, and with 2 spelling mistakes as well, and with 3 spelling mistakes as well. So every single moment in history is written in pi, with spelling mistakes and without spelling mistakes. Every single person that's ever lived name is somewhere in pi. And that still is not even close to the amount of digits in pi. That's a lot of digits.
Will we ever find an end to a pi?
No.
Okay.
They're looking for, obviously, they're trying to prove that it is rational, which means it can be written as a fraction. That's rational, stands for ratio, can be written as a fraction. But at the moment, this decimal cannot be written as a fraction, and I don't think ever will. There's a proof that it is irrational.
Yeah, but who knows? It might be. It repeats every 6 quadrillion digits.
I suppose we'll leave it as it's possible,
Yeah.
but I think it's been proved that it's impossible. Yeah. But there's computers probably working on it right now. AI is probably working on it, but we will never reach we'll never know the last digit of pi, which is kind of amazing because it's such a simple concept. And circles are present everywhere in the universe. that this number is present everywhere in the universe and yet is such a strange number.
So you always get that number if you're trying to find
Anytime you have the length of the circumference and divide it by a diameter of a circle, you get this number. But it's irrational. It's not like the number 3. It's 3.14159.265, etc. And that's weird.
forever.
That's weird. And it goes on forever, yes. And that decimal. So we use it, and we'll look at this number again in a second. I just want to show you how we use it. We can use it pretty simply, actually, because we use a rounded version of it, or a calculator version of it, to find the circumference. So the circumference can be found, if I just do a little rearrangement of this, if it's division here, it'll be multiplication there. It's pi multiplied by the diameter. So if it's division here, if I divide it, it'll be diameter times bigger. Well, this is it. We have to round pi in order to do this. And your calculator will round it, or you can round it. We usually use 3.14 by the diameter. So if the diameter of the circle is 10 centimeters, the circumference of the circle is 31.4, 10 times bigger.
You just round it.
You just round it. We use, for practical purposes, we round it. Because at some stage, if this was 3 centimeters, this would be 1 millimeter. This would be 4/10 of a millimeter. This would be 100th of a millimeter. This would be 5 thousandths of a millimeter. This would be 9/10,000ths of a millimeter. So you start thinking about, if it's measurement, we start to ignore some decimals like you did in your project, where you start to go, well, I'm just going to round, and I'm going to get a roundabout. Okay, but we also use it to find the area. So if we have a circle and we have a radius, an estimate for the area of the circle is, well, if I got a radius and I turned it into a square, and I got another radius here, and I formed this little square, I think about how many of those squares would fit the circle fit in?
4.
4. I think you can see that. There's another one over here, and another one over here, and another one over here. But that's too much. We got all these bits on the outside.
3.
So it's more than 3, but less than 4. It's exactly 3.14 of these areas, or pi times these areas. So the area of a circle is the radius squared times pi. It's not 4, because we got too many. It's not 3, because that's too few.
Wait, so
It's 3 and a bit times the radius, squared.
I thought the area of the circle. How do you find the radius? Yeah.
Well, you measure the radius of a circle, get the center, measure the radius,
So could you
square it, and times it by
Can
pi.
you just do A equals pi times pi r squared?
Yeah, so you could simplify this. A is pi r squared. It's seen a lot in formulas if you want to simplify it down.
Yeah.
And C is pi times D is often written. Or C is 2 pi or, because 2 radiuses is the same as the diameter. You can see that shortly. Lanny, sorry.
So can you write the letters instead of the entire word?
Yeah, if you want to write the letters. I'm just showing you what the letters stand for. So I'll do a very quick example, and then we look back at pi again. If you're working on your project, can you just be a little bit quieter, please, down the back? Milo? Okay, so if I have a circle, Schlock, thank you. If I have a circle with 10 centimeters as our radius, what is its circumference? What is the circumference of this circle? Well, it's pi times the diameter, which is 20. Pi times 20. Diameter is 20. Because 2 radiuses is a diameter. Now, pi, what do we use? Practically, what do we use for pi? We'll use in this class 3.14. We'll use a rounded version of pi, because it's just easier. No point using all of pi, because we'll never actually get an answer.
Yeah.
We'll be here forever, literally. So we'll just round it.
Wait, so the circumference is the area?
No, the circumference is not the area. The area is all the space inside. The circumference is the distance around the outside.
But you have the same.
No. The area is the radius squared, which is going to be 100 times pi.
Oh yeah, you're timesing it by 2.
All right, so this is going to be 62.8 centimeters squared. So you can use a calculator for that, that's no problem. You'll need a calculator for this unit and this test, so do use a calculator. Now what's the area of this same circle? The space inside is going to be pi times the radius squared. Now the radius squared is this square of 100, 10 times 10. So it's pi times 100, 10 times 10, which is 3.14 times 100, which is approximately 314 centimeters squared. Okay?
Very good.
Wait.
Amazing.
So make sure you have the formulas taken down.